factor, then care about the kind of rating?
Either order, right? You sort of have two different ways of thinking about this, which I suppose are technically different, but not super different. One of those ways is to just go straight for factoring, so we're looking for two numbers that add to 16, multiply to 63. 7 and 9. And then we can go into partial fractions from here. Right, I have degree 3 in the denominator, degree 2 in the numerator. Or alternatively, I have a factor of u up top and I got a factor of u down below. I can cancel them right now. And then factor that denominator. These two are equivalent because when you actually go and do your partial fraction decomposition on this one, you're going to find that the number, the constant, on top of u is. But as of this point, it is partial fraction decomposition. When you get your u antiderivative, just remember to max up. U is equal to e to the x. This one was a little bit tricky. Yeah. Okay, you found the substitution. Did you treat the dx? How did you treat the dx?
Let me look. I probably ain't even make it that far, but I know I picked e to the x as u.
Okay.
And then I went from there. But let's see.
Could you, like, in your brain, like, keep in mind that e to the x as, like, without, like, substituting it and factoring it? Like, would that work with fractions? So you have to do e to the x, and then e to the x plus 11 times e to the x plus 9.
Yeah, that would work. It's totally equivalent to what we've done, and I think, well, it's mathematically equivalent to what we've done. From the right-hand side, we're definitely equivalent. But, you know, if that's something folks can care about, but it doesn't seem to matter. Like, it's mathematically equivalent.
Then you wouldn't have to worry about
You do need to use sub at some point.
to fractionation or
Partial fraction. You
decomposition.
can, but you're still going to find certain difficulties with that e to the x. Once you get done with partial fraction decomposition, that is when you're going to need your u sub. You can either do that with the e to the x's laying around right now and just kind of ignoring their existence, or you can do the substitution first and then get rid of them. But you will need u sub eventually.
Okay, so you would run into the problem at some point.
Yeah. You would essentially run into the problem of after this partial fraction decomposition, you're going to have some u's in the denominator that you can't immediately get rid of without some kind of partial or without some kind of u sub.
Okay.
Yeah, Xavier.
So that you substitution we change the x to the lower stuff.
Yeah.
How do you connect these ways and say du isn't just e to the x and take e from the numerator?
That would work.
That would work just
Yeah.
fine.
I'm going to sit down and keep track of it. I mean, in all things mathematical, it's equivalent, but I think of it, me, myself, personally, I think of it as equivalent. Not keeping track of how many x is bad. Instead of like trying to just get rid of it. You know, if that makes more sense to you, go ahead and do that. Right, it's a book. All roads lead to Rome, as they say. That's a phrase you've heard before, right? I would just kind of date myself with that one.
Oh, no, it's just returning a joke right now. People are like putting it everywhere. I mean, it's not relevant. But it's relevant here. It's kind of reverse dating yourself.
Okay, I wasn't aware that I was doing reverse dating myself, but okay. Any other ones? And I still think there's one more tricky one.
Sign one out of one.
The arc sign one.
You're passing it. It's on the very bottom.
Oh, this one? Okay, we can leave that.
Just use up.
Yeah, that one's just use some.
Yeah. I was just trying to figure out which one you think is harder for us.
Now, if you remember your derivative of arc sine, which hopefully everyone does, that one should be pretty apparent that this one's so. U is arc sine, du is 1 over the square root of 1 minus x squared dx. So this would very quickly turn into the anti-idea of x times x, or times
Our sign is the square root of x squared.
yeah, derivative. The other one I think that is tricky is this one. Because it's not 1 plus tangent squared, it's quantity 1 plus tangent squared. Well, we only got about, 45-ish minutes left, I think. So I think we can transition here to some self-study time. Yeah, Xavier.
Question. That one, not just FOIL and then do partial fraction decom. Not partial fraction decomposition. The one where we're getting rid of power reduction.
Let's write it down. So what were you saying to do first, Xavier?
FOIL, change everything from the sign to cosine, power reduction, probably a lot of it.
Okay,
So
so
start using something. Am I crazy?
FOIL it out. Now change everything to sine and cosine.
Yeah. Does that not work?
I know, I'm writing it down. And it only doesn't work if, you can't quite make it work, right? And what are we calling it? Just the sine squared and cosine squared over there?
Yeah, I think so. Because then we can use sub, we can't use sub. I don't know.
Erase this bottom line. Or at least I personally thought that bottom line, so anybody else work on this one?
I'm thinking, use sub is tangent x, and then you have du equals secant squared x.
Okay. Yeah, we're kind of missing the secant. I mean, we can force one into there by multiplying and dividing by secant. But then end up with secant in the denominator.
Right. That would be secant x in.
Yeah. So I don't think this is quite helpful
Is there anything with secant for this?
in terms of secant. What do you mean exactly?
Like the 1 minus secant is equal to tangent, the square.
So this thing is equal to 1 minus secant.
So this is the cosine is equal to 1, then we get the whole.
Divide everything by cosine, right? So this is tangent. And then we subtract 1. So this is why I was kind of being super hesitant. You have your work kind of backwards.
Yeah,
That 1 minus secant squared. It's
Oh,
secant squared minus 1.
Yeah, sorry. Is that helpful or no?
Let me write it out first. Because it's definitely going to do something.
Yeah.
It's 9 plus secant squared to sub
Not quite, but the ones cancel out.
The ones cancel out.
I probably separated into two separate angles.
What do you mean by that, Zach?
So you have, so you multiply the secant here, so you have 2 secant 1 plus secant 2, but separate them as separate angles.
then
Over addition.
Alright, if you're going to do them separately, what's your first answer derivative?
The first derivative would be secant, well, 2 secant x
Yeah.
plus c. But the c is good.
Yeah, let's wait on the plus c until we actually have the final antiderivative. And what's the antiderivative of secant cubed?
I think we have that.
1/2, yeah, secant tangent plus the natural logarithm, the absolute value of secant plus tangent, and the absolute value plus c.
And then we can put our plus c there. Oh, wait, I think I did too many derivatives. There we go. That's all right.
So with the derivative method, in the base, just a bunch of
No test.
Just a bunch of trig identities. Algebra work to simplify, and then trig identity to get rid of that secant square, not secant, to get rid of that tangent square. And then you can do a bunch of direct integration.
question is don't integrate, but choose a method. Would you just make this method algebra? I don't know.
Algebra and trig identities.
Okay.
So 7.2 stuff.
Got it.
Right. That's sort of what like the intent of this one is going like, which section are you actually doing this out of? This would be 7.2. Alright, this is technically like 5.5. Right, this is just straight up U sub. And so is this one. This one is partial fraction decomposition with some trig identity shenanigans. This one, I believe, is U sub and a trig sub.
I'm sorry, partial fraction?
Yeah, why is that partial fraction?
Oh, IBP.
Yeah, sorry.
My bad. Okay, this is integration by parts, it's in U sub. And because we have this algebraic term out here of t, we got cosine and sine.
Yeah.
So if we follow lie, t is u, dv is sine t, cosine t dt. U sub plus trig sub, straight U sub. What about this one?
Fractions.
Okay.
Yeah, because we move the denominators to one higher than the denominator.
So if you're doing partial fractions on this thing, right?
Yeah.
Presumably that means you factor your denominator.
Is that the factorable?
Erica, you said, what's your factorization of that denominator?
Oh, I didn't do it. But
Oh,
I'm
okay.
assuming. I just assumed.
Hey, Hoang, you remember how to get your factorization, right?
Doesn't have a mesh.
Because it is a cubic. What's up, Hoang? I'm not hearing the end of what you're saying.
I mean, like, it's not going to be a good number.
Not a nice number?
Yeah.
Well, we can at least get one.
We had a negative I.
A negative I, that would be funny. Is this Swedish? I think this is Swedish. I have a lot of language stuff on my calculator. Yeah, degree 3. And it's all ones, right?
Yeah.
Looks like we got one root here of -1. Yeah, synthetic division. Which brings up Hoang's other comment of it looks like the other ones are going to be i's. Yeah, if they were not i's, then they would have shown up here.
How do you find roots again without calculating stuff?
Without calculator stuff, do you remember the rational root theorem from pre-calc?
I don't think he covered it.
Okay. So where do I want to write from here?
That's like the long one.
Unnecessary? I mean, if he doesn't have a calculator, it seems pretty necessary to me. I don't remember. So, if we have a polynomial in general form, and we want roots. There are very few methods that are actually available for actually figuring out roots. For general algebraic roots, once we get past degree 4, there is no like solid algebraic method of finding real roots. Because there is no such thing as like a quadratic formula type thing for degree 5. For degree 3 and degree 4, there is such a thing of like a quadratic formula. It's called cubic exponent. The formula is 2 lines long, typed up lines long. Quartic formula is 2 pages typed up long. And that's the reason why they did not teach you those in algebra class, I see. And there is no such formula for degree 500. What we can do, however, is instead of looking for real roots, we can look for rational roots. So we can look for roots of the form P over Q, where P and Q are integers. And there's the further thing that I'm going to assume here. I'm going to assume that P divided by Q has already been simplified as a fraction. So P over Q is not this. It'll be 1 over 3. P over Q is already simplified. Or the greatest common factor of P and Q is 1. They share no common factors besides 1 to cancel. It's all been simplified. I'm going to go ahead and plug this thing in, and we're going to assume that P over Q is a root. So when I plug it into this polynomial, I will get 0. So assume P over Q is a root. We have AN, and it's time to see if I can't figure out this argument on the fly, because I don't remember this argument. This should be. The only thing I remember is magic is going to happen. So we assume P over Q is a root. We plug it in. Because it's a root, we get 0. I am going to clear my denominator, so I'm going to multiply everything by Q to the n. So I have AN, PN, AN minus 1, PN. I wrote it wrong up here too. PN minus Q, A2, P2, Q, N minus 2, A1, P, Q, N minus 1, A0, Q, equals 0. Yeah, no, I got it. I'm going to subtract over A and P to the n. That's 2, isn't it?
That infinite series of Q is equal to that infinite series.
It's a finite series.
It's a finite
So you doing calculator work by hand?
I mean, I guess so. And the thing that I'm noticing on the left-hand side is all of these terms have a factor of Q. Right, we got a Q here, we're gonna have Q things all in these ellipses. We got lots of Q's here, lots of Q's there, and our maximum amount of Q's there. I got Q's everywhere. So I factor out a Q, I have whatever is left over in here is equal to negative AN P to the n.
And it's just equal to the highest degree that we have in the original equation.
Yeah, in the original polynomial. And this is where this assumption is kind of important. Q was a factor of the left-hand side. And because these things are equal, that means Q must be a factor of the right-hand side as well. And Q cannot be a factor of P to the n because they have no common factors. which means Q must be a factor of AN. It has to be. And we're going to come back up here, and instead of subtracting over a and p to the n, I'm going to subtract over a0 q to the n. When I'm done with that, over on the left-hand side, I have a p in every term, so I can factor out the p, and then it's the same argument again. P is a factor of the left-hand side, it's got to be a factor of the right-hand side. But that's this stuff, but negative. Can't be a factor from here, so it's got to be a factor from there.
So Q and P are a factor of A and.
No, that's not AN, that's A0. So P must be a factor of A0. And this result gives us rational root test, or rational root theorem. I'm gonna erase all this stuff here. If I have a rational number, and if that rational number is a root, then what is true is that numerator must be a factor. This is p, so the constant term. And the denominator must be a factor of the leading coefficient. So in the case of whatever polynomial that we were doing, the only rational roots that it can have must have a numerator with a factor of 1 and a denominator with a factor of 1. Which means it's either 1 over 1 or negative 1 over negative 1. Or negative 1 over 1 or 1 over negative 1. Which means we only have two choices. It's either got to be 1 or negative 1. Negative 1 happens to be 1.
Okay.
But rational root theorem gets you this long list of potential rational roots, and you just get to have fun and test all of them until you find them, which is where some algebra teachers go, this is a little unnecessary. Because usually for general polynomials, that list of possible rational roots is like 26 numbers long. That's going to take you a long time to chew through every single one.
So this only for cube, not odds.
What do you mean?
Like for one, like the one of the roots got to be 1 or negative 1. You know?
No, this is for every polynomial.
Oh. Okay.
Right, so this would be for, you know, something like 6x to the 9th plus 8x squared plus 7x plus 5. Right, the only rational roots this thing is allowed to have is rational roots where we have a factor of 5 up top and a factor of 6 down below.
Oh.
So we got 1, negative 1, 5, negative 5, 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So we're going to have 1, negative 1, 5, negative 5, 1/2, negative 1/2, 1/3, negative 1/3, 1/6, negative 1/6, 5/2, negative 5/2, 5/3, negative 5/3, 5/6, and negative 5/6 as potential roots. And we just gotta go figure out which one it is. So that's what you would do if you didn't have a calculator. Sorry for the
Yeah, that's like a cheat code.
20-minute side tangent.
Yeah, my bad. I just didn't get this covered.
That's beautiful.
Let's go back to the original problem, right? We need to factorize this thing. And we know that x equals -1 is agreed. This is where synthetic division comes from. So we have x squared plus 1. So my factorization is x plus 1, x squared plus 1. And so down the bottom, for the partial fraction decomposition, we're going to have a linear factor and an irreducible quadratic. So in our partial fraction decomposition, we get a over x plus 1 plus bx plus c over x squared plus 2. And then go through partial fraction decomp.
Okay.
So like you heard of the partial
I could do it.
Even though I got my own thing. I'm glad we ain't got no quiz. Oh, I should have asked him if we do it Monday. I'll email him. Even though I got my own TV and my own CD, I still the same boy. My legs hurt so bad, I literally just sat down for 4 hours at home stressing over that. Just to not even have nothing. Just add an extra stress on me and little too many. It just ain't right. It just ain't motherfucking right. Fucking legs hurt. I need a wheelchair. I need a wheelchair. Ooh. Baby gonna come out with a tumor. That's a little tumor. I ain't got no baby. I don't know nothing about that queen. I don't know nothing about that. Y'all be hating. Y'all be mad. Y'all be mad. Morgan Wallen. Get your ass on. Even though I got my own baby and my own TV, I ate some tropical smoothie. Whew. We know we gonna be all right. No weapon formed against me is prosper. Hear me, man. People that really believe words have that much power are idiots. And 9 times out of 10, they don't be living life to the fullest. Cause they're literally idiots, literally. That's like them super religious Christians that like literally believe the word for word instead of deciphering it for your motherfucking self. Just dumb. Just fucking dumb. Even though I got my own CD, my own TV, the same oldie. 'Cause even though I got my... Lord have mercy. mercy. Lord have mercy. It's music and words. Excuses they make for themselves when they in certain positions. Amen. But I ain't gonna preach to y'all right now. I ain't gonna preach to y'all. I ain't gonna do it to y'all today. Oh Lord. What the hell is this? I ain't gonna preach today now. Not today. I ain't gonna preach today. I really could have stayed at home. I just ate. Hey, Queen. I'm finna restart this, though, because my phone glitching. I actually might sit here till 3 o'clock just to get my daily parking, because I paid $3 to get here. I'm finna motherfucking get my $3 worth, honey. I promise I am. I promise I am. I swear you just had lashes. I swear you just had lashes.